of buoyancy. So the most important concept is cause of buoyancy or buoyant force. So all of you notice it. So what is the cause of buoyant force? Let us discuss now. So before going to study this, I want to teach you two properties which you already studied in 8th class and even yesterday's class also I have taught you. Now, for example, imagine if there is a swimming pool or there is some water log. Now you can see, suppose some X person is standing vertically like this. Imagine now. Now you tell me, his legs will experience more pressure or his head will experience more pressure? That is what is my question. Everybody, who will be deeper inside? So as we all know, even 8th class we studied. For example, if this is a liquid column, if you are swimming here and if you are swimming here and if you are swimming here, who will experience the greater pressure? Yes, please. Yeah, Kishore is having questions. Sir, if a plastic ball floats on the surface of the water on Earth, will it float or sink if placed in a bucket of water in the moon? Kishore, that is based upon the weight. We will discuss with Kishore. Okay, wait. Clear? Understand, Kishore?
Yes, sir.
Yeah. Now, tell me in which case. This case I'll take P1. This case I'll take P2. This case I'll take P3. Where the pressure is greater, guys? I want to ask you.
Sir,
Yes, please respond, everybody. So P3 is greater than P2 is greater than P1. You all should tell me, everyone, now. So we all know that if you go more deeper into the liquid, so the depth of the liquid increases. So pressure, what will happen? Pressure also increases or decreases, everyone? Depth of the liquid increases. Pressure will increase. Understand? Now, for example, in a given depth, now for example, Mr. Lingesh is swimming here, Mr. Nivedan is swimming here, Mr. Kishore is swimming here, Mr. Mari is swimming here, or some other is swimming here. Now tell me, they all are at the same depth. So they will experience the same buoyancy force or different buoyancy force. Everyone? At a given depth, pressure is experienced by all the direction C's. Yesterday also I told you, that is only call it as some law. What is that law? Pascal's law. So what is Pascal's law? Will says that in a given depth, the pressure experienced by all the directions. What is that, everybody? It is uniform. Purima. So that is only uniformly distributed. That is what we used to call Pascal's law. Yes or no, or respond, otherwise stop the class. Is it stop? Clear, everybody? So with the help of these 2 points only, we are going to study the cause of buoyancy force. The more deeper you go, your body will experience more buoyancy force. Suppose if you are swimming, you are swimming at the particular height, sometime at this point, sometime at this point, sometime at this point. So at this given depth, you will experience same pressure or different pressure. Everybody? Yes, please. Same pressure. Understanding? So at a given depth, pressure is same always. That is what we used to say Pascal's law. Now, coming to the cause of buoyancy force. Now imagine there is a bucket of water. Now, I ask, imagine different height it is. So liquid. Now, or else there is a swimming pool, you can say. So I will say Mr. Sam to stand inside the water swimming pool. He went and stand. He kept the legs at the touch of the bottom of the swimming pool and he's standing there. Now you tell me, his head is here, his legs is here. So which part of his body will experience the greater buoyancy force? That is what is my question. Yes, Shivani? Kishore?
Sir, legs.
Legs. Why legs will experience the greater buoyancy force? Anybody? Hasini, Sudhakar? Yes. So compared to the head, the legs are very deeper into the deeper. So that is why. So if I take the pressure at head is P1, pressure at leg is P2. So which is greater? Everybody tell. P2 is greater than P1. P2 is greater than P1. Understand, Ara? Everybody? Mukesh?
Yes, sir.
Prithvi, anything doubt you can ask me. So that is very, very important. Now, same way, with the help of this, we are going to study cause of buoyancy. So let us take the cause of buoyancy. I will take the beautiful image and then from that you can. So imagine there is an object whose weight is W, So it is immersed in the water, fully immersed in the water. So we all know, because buoyancy force experiences maximum when it is fully immersed or partially immersed. Everybody, fully immersed. Understand? So let me take the upward force, the weight of the object which is acting downwards. The weight of the object which is acting downwards. I am putting, forgot about this black arrow, downwards. So that downward force we used to call something that is only weight. Am I right or wrong, everybody? Weight of the force, downward force, which is what? Let me take F1, downward force. So now this object will experience from the bottom of the liquid, there is upward force. That upward force, let me take it as a F2. What is that upward force, everybody? Yes, F2. Now, let me take, all of you observe very carefully. This object is having two surfaces. I will take this surface is upper face. Upper face. Am I right or wrong? And this surface is the lower face. Shivani, any doubt, Shivani? Kavya? This is upper face and lower face. Now, upper face is at this height and lower face is at this height. Now, you tell me, according to you, who will experience the greater force? Upper face or lower face? Where the pressure is greater? That is what is my question. Everybody. Lower face is more or upper face is more? Anybody? Who is more deeper? Lower face or upper face? All of you?
Lower face.
Lower face is more deeper than the upper face. So who will experience the greater buoyancy force? Yes, please. Who will experience the greater buoyancy force? Mr. Sam? Niroshi? Who will experience the greater buoyancy force? Everybody. Lower face. Because lower face is more deeper. Am I right or wrong? Everybody? Yes, please. So that is.
Yes, sir.
So here there is a greater force because the pressure, you can see you can notice it. The downward direction is basically, imagine it is upper face is at the topmost, so that here it will experience the less pressure compared to the lower face. Understand? So now if you take it, so here the force is, let me take, I want to find what is the force. So downward surface, it is experiencing what force actually? Upward force, that is what F2. Upward surface which is exerting, pulling downwards, that is what actually F1. So if I want to find net force, what is the net force between them, between the two surfaces, upper face and lower face? Then the net force is equals to the differences between the upper force and lower force. So that is only call it as net force. Net force is equals to upward force minus downward force. So based upon this result, the result may be 0, result may be negative, result may be positive. Based upon that, we will say positive buoyancy, negative buoyancy and all. That is all we will see in the next class. Now you remember, if you want to find the net force, so what we have to do it, guys? Everybody? Yes, please. Net force is equals to buoyancy force minus weight of the object. That is what? Upward force minus downward force. So you can see the net force on the body is in upward direction is the buoyant force, and which reduces the weight of the body. That is the reason why we are feeling lighter when we are into the liquid compared to the air, because of the buoyant force of the liquid will makes us to push upward direction. That is the reason our body feels less weighter. It will reduces the weight of the body when you immerse it in the liquid. Now, all of you observe very carefully. So then what about the right side and left side? Let me take at this depth. This side pressure experiencing is like this. This side pressure experiencing is like this. Both are same amount, because at a given depth, both are same. So that, let me take, this is F3 and this is F4. So F3 and F4 both are equal or equal and opposite. So that what is the net resultant force? Anybody can tell? Net resultant force. Net force is equals to how much, guys? This is positive and this is negative. Yes, please. What is the net force in a side? You all should tell. I should not. And let me take at this depth. At this depth, I will take it. This particular part. Let me take this is F5 and this is F6. Now tell me, this F5 and F6, both are equal or not? Everybody?
Yes, sir.
Yes. So what is the net force? What is the net
Zero.
force equals to 0? Let me take at this depth. Let me take F7 and this is F8. Now tell me, F7 is equals to what? Everybody? F8. So that what is the net force? Net force is
Zero.
equals to what? 0. So if any body will immerse in the object, only which surfaces will experience the force? Upper surface and lower surface. Understanding? So upper surface and lower surface only they will experience the force. Then remaining all this horizontal place, always the force is equal and opposite. So what is the total net resultant force? Anybody can tell? Net resultant force on this. Please respond. Right side is equals to left side, so that they will cancel the effect of each other. There is no effect on the body by these horizontal forces. Only the effect is what forces? Vertical forces, either downward, vertically downwards or vertically upwards. That is only cause of buoyancy force. So only body will experience what forces, everybody? Downward force and upward force. So horizontal forces is always equal, because at a given depth, horizontal level, pressure is remains same or different? Everyone speak, guys. All of you. Pressure at a horizontal level is remains same or different, guys? Same level, it is
Yes, sir.
remains same. So that therefore any effect is there or not? Therefore, no effect on body by horizontal forces. Please remember. Nivedan, okay ra? Mari, Kishore, understand now? So only body will experience it, upward force and downward force. So this is the cause of buoyant force. Why buoyancy is exerting? Why you are feeling lightweight? Because the upper part of the body and lower part of the body is not experiencing the equal force. That is why it is cause of buoyancy. So I hope you all understand. Anybody can ask me, you heard. Okay? Or else write the statement. So the difference in pressure on the upper and lower faces of a body, on the upper and lower faces of the body, on the upper and lower faces of the body, immersed in a fluid, gives rise to the immersed in a fluid gives rise to the upthrust exerted by the fluid, on the body in upward direction. Once again, I'm saying you write it. The difference in pressure on the upper and lower face of a body, immersed in a fluid, gives rise to the upthrust, exerted by the fluid on the body, in which direction? In which direction? Upthrust always will exert in which direction? Buoyancy force.
Upwards.
Upward direction.
Upward direction.
Upward direction. Understanding? So that is the cause of. Understand, Mari? Everybody? Simply, if somebody will ask you, what is the exact cause of buoyancy? All of you listen. Very simple. You can say, if any body is immersed in the liquid, upper face and lower face, they will never experience the equal force, because they are in a different depth or same depth. Different depth or same depth? Everybody? They are in different depth. Upper phase and lower phase, they are in a different depth. Do you understand, Mari? But horizontal force, the effect of horizontal force is 0. Because on a given depth, the net force experienced by the liquid is what? 0. Because equal and opposite. Purima, understand everybody? Yes? All of
Yes,
you?
sir.
Yes.
Only pressure difference is exiting where? Upper phase and lower phase. Purima, Sam?
Pressure difference, can we say net force?
Net force, that's what. If you want to calculate net force, net force. But basically pressure will say, because it's a liquid pressure, that's why. Purima,
Yes.
that is what. Understand, Amma? Shivani? Kavya?
Yes,
Yes.
sir. Yes, sir.
This is what it is. So draw the diagram also. So if you want it, I will again you draw. You can draw like this. You can put it over one beaker of liquid. You can make it. This you write upper phase and this you write lower phase. So upper phase you can put up thrust, upward force, F2, and downward you can put downward force. What is that? Downward force only we used to call something. Anybody? Downward force only we used to call something. What is that? Weight, guys.
Weight.
Weight of the object. And this is horizontal force. So horizontal force is what? No effect on the body, because at a given depth pressure is remains what? At a given depth pressure is remains constant. Alfin, tomorrow onwards don't join, Alfin. You are not at all doing anything, I know. I want to see the classwork. I'll take next week offline class, correct? I'll check it. Are you writing, Alfin? Do you understand or not this concept? Cause of buoyancy. Yes, please act to Alfin. Physics will become very tough otherwise, I'm saying. So horizontal level, what will happen, guys? Remain same at the point on the horizontal level. Remember that. Okay. So pressure increases with the depth and pressure decreases when body is coming up. So which part will experience more? Upper part or lower part? Upper part of the body or lower part of the body? Lower part.
Sir.
Understand? So lower part is more deeper. The more deep you are, the pressure is increases. That is what you have to write it.
This will be more.
Yes. So that pressure difference only causes for what? Buoyancy. Do you understand, everybody? Upper phase and lower phase will experience a different amount of pressure. That is only cause of what? Cause of
Buoyancy.
that is what you have to remember. Okay, everybody. Now there will be a question for example, maybe somebody's mind. Sir, the object will float in some cases. The object will float within the liquid in some cases, and the object will sink in the some cases. Now, which one will experience the buoyancy force? That is what is the question. Anybody can ask? Sometimes object is floating above the liquid, within the liquid, and finally sinks. Which one will experience the buoyancy force? Anybody? Smart and tell. Be smart and tell. Who will experience the buoyancy force? 3 cases. One case above the liquid, another case
Sinking.
another case sinking. Who will experience the buoyancy force?
So sinking.
No, Sam.
So the
Every
first 2 cases.
every case it is experience the buoyancy force, but sinking or floating or sinking above, floating above or within the liquid is depends on weight of the object. Do you understand, everybody? That we'll discuss in the next class. So every case, either object will sink or object will float or object is partially immersed or object is fully immersed, doesn't matter. Every object will experience the what force? Everybody? Buoyancy.
Buoyancy.
That is what you have to remember. Purima, Abhirami, Gokul, clear?
Yes, sir.
So doesn't matter either it is sink or float above the surface or below the surface. Every body will experience the buoyancy force. That is what you have to remember. That is what I can say. Okay, guys? Purima, Sam, hey, Mr. Prithvi, understand? Nivedan?
Yes, ma'am. Yes, sir.
Yeah, please make it. So this is what is all about cause of buoyancy. Any doubt you can ask, otherwise you can. And tomorrow I will teach you what is the concept of density, relative density, and then we'll go with the Archimedes principle. After that, we'll study what is the importance property of buoyancy. There I will teach you the formula, and then we'll study principle of flotation, floating and sinking. These are all the things we are going to discuss. Don't worry, this will be the most important and very interesting topic. So you all can experience something new which you are learning. So you will be having class 9th, you'll be having entirely theory concepts, but here we'll make every theory concept will be having a formula. That's all it is. Okay, everybody. Thank you, everyone. We'll meet tomorrow's class. Tomorrow I'll teach you negative buoyancy, positive buoyancy, and zero buoyancy. Negative buoyancy, positive buoyancy, and what else, everybody? Yes,
Zero
please.
buoyancy.
Zero buoyancy. Okay. When the body will be experiencing positive buoyancy, when the body is experiencing negative buoyancy, and when the body experiencing not negative buoyancy, neutral buoyancy. Puriyama, that we will teach in the tomorrow's class. Anybody having any doubt, you can ask me, or else tomorrow we'll meet. Is it okay, everybody?
Yes, sir.
That is. So thank you, everybody.
Yes, ma'am.
Tomorrow's class.
Yes, sir.
Thank you, sir.